I used the Colab for the model training and prediction. So you can also use this. It's free. You can log in your Google account and upload your file IPYNB. Then you can use the resource. So there are three models here. First is the random forest model. That's most simple model in this demo. And the second is a language model. I know there are some large language models can give you a very good answer, so it can save you a lot of time, and it's very helpful. If you want to use a language model, you can train it and deploy it to your project. And for your project, it's not required to train a model from scratch. You can use a pre-trained model. Download the pre-trained model from any website, then deploy that model to your project. That works. And for the third model is the image classification. It's about the pictures for many applications and many situations. You want to use the picture deep learning model, so you can start from here. So let's go through the code from the first model, a random forest model. First step is import all the libraries you need. Click the button here, it will start running. Then when it's finished, you will see the green check mark here. Here, that means it's good, it's finished, and there's no problems. So then you can move on. And I put everything related to this model here. And this part is prepare the dataset. There are some existing libraries, they have the dataset. You can load it directly instead of clean the data and find the data and prepare for your model. You can save a lot of time for your project. And then train the model. Use the random forest model, and call fit means training. And then save the model. Save the model means after training it will be a trained model. Save the model to a file. Then load the model for later use for the prediction. And here is the prediction. Predict what? Predict this example. Maybe you don't know the numbers meaning in this data. You can check the dataset to find the comments and explanation about these numbers. So they call this, the machine learning people call this average feature value. Each value it represents a feature. So it has 4 features for this data. And we give the data to the model and let the model to predict what is the output for this data. Okay, now let's click. It's finished, and the output, the prediction is this. So this is how this model works. And for if you save the model, like here, you can check your models, the file here. All the files are gonna be saved here. So let's move on to the second model, language model. You can import some libraries you need for your model. In this model, I use the PyTorch. There are mainly 2 deep learning model frameworks, PyTorch and TensorFlow. We will use both. This one, model 2, is the PyTorch, and for next model, we'll use TensorFlow. This importing is slow because it's huge and takes time. Okay, now initialize your model. Here the model, I used the Distill GPT-2 and do the tokenizer. Okay, it's finished. This one is fast. Next is load the dataset. I downloaded the dataset from here. It's Shakespeare text, and I only used the first 5,000 characters to train the model. The more you use, you will get a better, not necessarily better, you will get a more accurate model. Let's start loading. This one's fast. It's already finished. Then we can train the model. Training model usually takes a lot of time. It's the most time-consuming part for model. So there are many optimizations you can do. You can adjust these parameters to change to improve your training speed, and sometimes it can improve your accuracy, improve your accuracy and training speed. Sometimes it doesn't. You have to try. Okay, this training is fast. It's 47 seconds. And after that, after training, you already have the trained model. Then you can save the model. You should save your model, and it's here. If you open it, the model is here. Now you need to load the model. If you don't want to train the model, just want to load the others model, you can start from here. Store the model to a folder, and then you can do the prediction. Let's predict. And for the prediction part, for this model, we need to give a prompt, which means we give this, and let's see how the model continue this. And the result here is this. It already gave the very good result based on our training process. Because it's very small training. It's only takes 5,000 characters, so it's a good result. Sometimes you will see a different result, or you will see the output doesn't make sense. That's because the training is not good. You need to tune the model, adjust the parameters. Also, you need to check your data set. Model 3 is the image classification. If you want to work on images, you can use the image model. There are many deep learning models for either image or video, so many different models. Image classification is the most simple one. Higher level is like the object detection, and if you use the 3D model, you can use the nerve, how to change the 2D picture to 3D. So a lot of models you can use. It's really up to your project, what idea or what features you want to use. And okay, the import is completed, and the TensorFlow, we use the TensorFlow for the image classification. And now we load the dataset. The dataset is CIFAR 10. It has some images for these classes: airplane, horse, ship, bird, truck. So it's very tiny data set because the images are small. You will see how small very soon. And after the loading data set, we should load the model. And here I'm not using existing model in the library because they are relatively large, so I use a small one. It's this model is built from scratch. It's very small, but it has a good result. You will see that. And then compile the model. You need to give the optimizer and some a loss calculation matrix, and then train the model. To train a deep learning model, it takes time. Here I decreased the training time with tuning some parameters. The most important one is the epochs. Epochs means how many repeat you want to use the same data set to train your model. Epochs 1, that means I just want to use the current data set once to train the model. If you want to train the model more times, you can change the number to 10 to 100, but be careful with epochs. It doesn't matter. It doesn't mean the higher the better. So the epochs is related to overfitting issue. If you just trained like once or twice, the model gonna be underfit, which means you haven't utilized all performance of the model. But if you train the model with too many epochs, that means you trained too much, changed the model too much. That's called overfitting. The accuracy gonna decrease if your model is overfitting. So this train is fast. It's just 1 minute, and you can see the accuracy here is 36%. It's lower than the last time I trained. It happens because it will shuffle the image, train the model with the different data sequence, and you would get a different accuracy. You can train the model several times and then save the model and then use the best model. Now we can save the model. And after saving the model, we can load the model. If you don't want to train the model from scratch, then you can start from here. But before loading the model, you need to check your model's format. Here is Keras. Okay, now let's move on. Evaluate the model. We need to check the accuracy, test accuracy. Here you can see the test accuracy is about 60%. It's good. It's good compared to the training accuracy. So thinking of our epochs just 1, so this is a very good result, 60%. Let's move on to the prediction part. And the prediction has a lot of code because it's for the visualization. It's not about training or prediction. So the results are here. The green labels means the correct prediction. The red means wrong. And here you can see the picture quality is very low, very low. You cannot really see a cat here, right? It's based on your training model. If you train it to know this is a cat, then it will know it's a cat.